Hello, welcome to this short video on how to use the multi-agent coordination framework in order to simulate a robot amidst pedestrians. This scene shows a robot moving in gray that would turn green if it waits for a pedestrian, and several pedestrians in yellow that would turn red if they're waiting for the robot. What does this waiting mean? Since the pedestrian trajectories were recorded in the ATC environment that you see in the picture here. It's from Osaka, Japan. Since they were recorded without a robot, this simulation essentially helps us move a robot about in this environment wherein the robot will respond to the pedestrians and the pedestrians will respond to the robot. So these polygons or envelopes that you see are essentially the sweep of the robot or pedestrian's footprint along their trajectory. You have arrows that represent a precedence constraint, essentially saying what agent will wait for what other agent. These are computed centrally and online. So although these are very far apart, you might see an arrow, but when this only means that somewhere along the path there will come a situation where one has to yield for the other. Let's look at a video of how this works. I now start the scripts that start the simulator. So here you see these arrows developing. This means that somewhere along the line the robot will have to wait for this pedestrian. That's 165. These numbers are simply the path indices of the respective agent as it's moving along. Here you see that the pedestrian is slowing down, but this is natural. This is not related to the presence of the robot. Uh, as you can see, it's still moving, so it'll go to waiting if it is affected by the robot. However, here the robot has to wait because the arrow is pointing towards the pedestrians, and waiting turns its color to green. Now that the agent has passed, it starts moving again. You see another arrow here that points from the agent 236 to robot, which means that the agent will probably wait. Now the arrow has actually turned the other way since the agent was closer to this area that was contested. So, so in the end, neither of them had to wait because that was an easier solution. Here's another example from the same set of start and goal points for the robot. Something similar would happen. Maybe we could look closely at this arrow here from the robot to the pedestrian. Let's see who stops. But since this is computed online, those arrows might actually change direction. And the robot didn't wait this time like last time. Here probably neither one would wait, and the arrow is in such a manner that the robot has to wait actually, but it didn't have to because the agent had already passed the critical section. Thank you.